Okay, in these compound inequalities, we're trying to isolate the x, and in this case, it's in the middle of these two inequalities, and when it's looking like this, we have to do it to each side of these inequalities. Now, I've seen some students kind of make like lines like this to indicate like where the sides are at so they can see that. So if we do something in the middle here to isolate the x, we have to do it on this left side, and we also have to do it on this right side. So I'm going to erase those lines so things don't get confusing, but I wanted to show you them. Okay, so trying to isolate this x, we need to add 2 to each side. So I'm going to put plus 2 here. I'm going to put it under that one. Now I have to do it to this side of the inequality as well, so plus 2 there. And I have to do it to this side of the inequality. Let me write now what I'm left with. So negative 11 plus 2 is negative 9. Is less than, and I'm left with 3x in the middle, which is less than, and 4 plus 2 is 6. Okay, so now I'm trying to isolate this x still, and it's 3 times x. So the inverse operation to multiplication is division. I have to do divide by 3 here, divide by 3 here, and divide by 3 there. When I do that, I'm going to be left with negative 3 from the negative 9 divided by 3. Is less than, the x is now isolated, which is less than 2, because 6 divided by 3 is 2. Now I'm going to graph this on my number line. Because this does not have an equal to symbol underneath of it, it's going to be an open dot at negative 3. So open at negative 3. And this one does not have that equal sign underneath there either, so it's going to be open at positive 2. And then I'm going to combine those because x is between those two quantities. So here's my line. Okay, next question. In this one, I have an OR situation. When I have an OR situation, I need to solve each of these individually, and then I'm going to graph them over here. So looking at this one right here, I have 5x plus 7 is greater than or equal to 7. So my very first step is I'm going to subtract 7 from both sides because the inverse operation to addition is subtraction. So subtracting 7 there, subtracting 7 here. I don't know why that's in there. No. I'm going to be left with 5x is greater than or equal to 0. Let me put my equal to symbol in there. Good. Now the inverse operation to multiplication, as you can see right here, this 5 is tied to the x by multiplication, is division. So I'm going to divide both sides by 5. And when I do that, 0 divided by 5 is just 0. So I'm going to get x is greater than or equal to 0. And that's one of my solutions. So I have this, or, and I'm going to now solve the other one. So coming up here, I have 2x minus 5 is less than or equal to negative 13. So I'm trying to isolate this x, so I'm going to do the inverse to subtracting 5, which is adding 5. I'm going to do that over here. And then I'm left with 2x is less than or equal to, and I'm going to add these two things together. So negative 13 plus 5 is negative 8. Let me put my bar in there because it's very important that you keep the symbol the same. Okay, now I'm trying to get this x alone, so I need to divide by 2 on both sides. So divide by 2 here, divide by 2 there. Now I'm left with x is less than or equal to negative 4. Let me put my bar in there because it's very important that I keep that correct. Okay, so here's my solution. I have x is greater than or equal to 0, and I have x is less than or equal to negative 4. So that's my solution, so let's plot it. Because there's that bar underneath, I'm going to have a filled in dot on the 0. Now it's saying x is greater than or equal to 0. So I'm going to point to terms that are greater than 0. If you indicate, or if you put the arrow here, it indicates it goes on forever. So please put the arrow on there. Now the other option is or x is less than or equal to negative 4. Since it can be equal to, I'm going to put a filled in dot at negative 4. And then my arrow is going to point to things that are less than -4. And that would be a complete answer for this question.